Welcome to Lesson 2 of the Introduction to Python course. In this lesson, we will be discussing functions and modules with a focus on defining and calling functions, parameters and arguments, default values for parameters, variable scope, return values, and creating and importing modules. Now, we've already seen previously some of Python's built-in functions. In this lesson, we'll learn how to write our own functions. Let's have a look at the syntax of a function. Functions are defined using the def keyword in Python. So we have def function name. All right, and we shouldn't forget the brackets here, followed by the colon. Then under this, we provide indentation, and this shows that we are inside of the function. Inside the function, we can have any kind of content, and yes, indentation, and then we tell the function to do something. Now we exit this function by removing the indentation. So this is outside the function, and then we do something else, whatever else we want the program to do. And that is the basic syntax of a function in Python. So now let's look at an example. If you remember, we had an exercise where we wrote hello. So let's try to do the same thing, but a slightly modified version of it. So we will define our function as say hello. Then we will define a variable, your name. And we will input what is your name. So this way we will be inputting a string from the user, which will be their name. And then we will print hello, your name. Sorry, this doesn't come within quotation marks. So your name, which is a value that the user will be providing us with, and then exclamation mark, and we provide a separator parameter, which will be empty, and that's it for this function. Now we define a second function, which will be our main function, and we call our previous function within this. And that's it. Now when we want to run these functions, all we have to do is call main. So we can see that Python, the program, is asking us what our name is. So let's just give example name here. Let's say George. And it tells us, hello, George. So you can see that the code works in the same way as we had seen previously, but the major part of the program is within this first function, say hello. We also define the main function still, but instead of defining the entire, all of these different steps within the main function, all we do is use this main function to provide the flow of the program. So we can see a little more about how this works in this next example. So let's define our function, say hello. Once again, the brackets are important. Now we will have a variable, your name, which we input from the user with the question, what is your name? Then we will add an extra function here called insert separator, which we will look into in a minute. And then we will print hello, your name, exclamation mark, and we will provide a separator parameter. Now we define our next function, and this function is the insert separator function. Now under this function, we say print equal to, equal to, equal to. We'll see how this works once we run this code. Now we define a new function called recitePoem, and within this we say print. How about a Monty Python poem? Now we call our function insert separator. Then we print, much to his mom and dad's dismay. Sorry, that was a complete mistake. Print Horace ate himself one day. Print he didn't stop to say his grace. Print he just sat down and ate his face. Now I know this is kind of a silly poem, but you know, it's a Monty Python poem, so it does justice to the show. Now we define a function, say goodbye. We print goodbye. And now we define our main function, which is say hello, insert underscore separator. Then we have recite poem. Then we have insert underscore separator. Then we have say goodbye. Now we call our main function. So the program asks us what is our name. So let's give another name now, Sarah. And as you can see, the program now prints what is your name, and we have inputted Sarah. Then it inserts the separator as we have mentioned here. And it says, hello Sarah. Then it inserts the separator and it says, how about a Monty Python poem? And inserts the separator. Then it prints out the poem, once again inserts the separator and says goodbye. So this, as you can see, is how we can control the flow of a program with several different functions, all by using the main function. Now there's a little note over here that I just want to quickly read out to you. So not all Python modules are programs. Some modules are only meant to be used as helper files for other programs. Sometimes these modules are more or less generic, providing functions that could be useful to many different types of programs. And sometimes these modules are written to work with a specific program. Modules that aren't programs probably wouldn't have a main function. Alright, so with that done, we can now move on to variable scope. Now, if you noticed in this code that we have just written, now if you've noticed in the previous code, we did not use the user's Now, if you've noticed in the previous code, let's go back to it. All right, so you can see in this code that we have your name, in which we took the user's name as the input. However, we do not use this variable in this little function over here to say goodbye to the user. Now the reason we didn't do that is because the say goodbye function would not know about this particular variable, your name. That is because the your name variable is local only to the first function that we had placed it in. So over here, your name is local to say hello. So it would not be known to any of these other functions. Let's see this next code. So we will define a function set underscore x where we have x equal to 1. Now we can define another function get underscore x. Sorry, we need the brackets. It's very easy to forget to put the parentheses there. Now we say print x. Now we define main with set underscore x and get underscore x. And then we call our main function. You can see that this throws an error. This is because x is defined in the setX function and is local only to that function. Now when we try to use x in the getX function, getX does not know what the value of x is because it has not been defined within this function. Now let's have a look at global variables. Global variables are basically defined outside of a function rather than inside the function. Let's take a look at an example. Let's say we defined x is equal to 0 outside the function. Now we do the same thing we did before. We define set underscore x with x equal to 1, and then we print from set x and we print the value of x. Next we define, this would be get x. So next we define get x with brackets and a colon, and we print from get underscore x colon, and we print x. Now we define our main function with set x and get x, and then we call the main function. So as you can see, from set x, the value of x is 1 as we have defined it here. From get x, the value of x is 0 because it has been defined here outside of any of the functions. This happens because x in this case, printed outside of the functions, is a global variable. So let's take a look at what global variables are. Global variables by default can be referenced but not modified within functions. So as you can see here, we referenced x within this function, but we cannot modify it in any way. Now when a variable is referenced within a function, Python first looks for a local variable by that name. If it doesn't find one, then it looks for a global variable. So for example, in this first case, when we called x over here, the program looked for the value of x within the function. It found that the value of x is defined as 1, and so it printed x as 1. In the second case, we did the same thing, but when it looked for the value of x within the function, it found that it was not defined. So then it looked outside of the function within the program, and it found that x was defined here as 0. And that is why it printed the value of x as 0. Now when a variable is assigned within a function, it will be a local variable, even if a global variable with the same name already exists. This is what we have seen here. So we defined x as a global variable outside the function, but within this function set x, since we have defined x within it, the value of x is taken from this rather than being taken from outside. Now, if we do want to modify global variables within a function, we need to explicitly state this, and this can be done with the help of a global keyword. So let's see the following examples. So let's define our global variable x, then we define our function setX. Sorry about that, this is setX. Now we say global x, and then we say x equal to 1. Now we say def get x, and we print x. Then we define our main function, and within it we call setX and then getX. Now we call our main function. So you can see that the code prints 1 because the setX function has explicitly referenced the global variable x. Now there's something to note over here. So some developers feel that the use of global variables in general is not a recommended way of programming. For this, there are two recommendations that you can feel free to follow. The first is to prefix your global variables with an underscore. So this will tell anybody else who uses the code, including yourself, that the variable is global, and it reduces the possibility of this particular variable getting confused with any other local variable that has the same name. It is also just a convention that helps developers to know that these variables are not meant to be used outside of the module, for example, by programs that are importing the module. The second recommendation is that wherever possible, it would be better to design the code in such a way that the values can be passed on from one function to another using parameters. So in this way, you can reduce the chances of getting confused and mixed up with global variables. Now let's take a look at function parameters. So let's consider the insert separator function that we had used in the previous example. So just to recap, it looked something like this. We had def insert separator print equal to equal to equal to. Now, it may so happen that we would want to have different types of separators. So one solution for this would be to create multiple functions, but that would get quite tedious, and it would also be difficult to maintain. So a better solution for this is to use function parameters. The syntax is like this. So we define our function. We define our function, and within this function, we provide different parameters as needed. So let's say we have parameter 1, parameter 2, and parameter 3. Now we tell the function to do something, and within this, we input the parameters. So we have parameter 1, parameter 2, and parameter 3. So this is just the basic syntax of how to do this. Let's now look at an example. So we'll use the example that we used before, the hello program. So we define our function, say hello, and we print hello, your name, sorry, actually in this case it would be name. We will see this a little later. Then we have the exclamation mark, and we have the separator. Now we define our next function, which is insert separator. Within this, we define the parameter s. Oh, I'm sorry, I forgot. So within this function, we define the parameter name. All right, now under the insert separator function, we print s, 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 and then the separator parameter. Now we define recite poem. Under this, we print. Okay, so in this case, let's go for a slightly shorter poem that we can print here. So let's print Baba Black Sheep have you any wool? And then in the next line, we will say, yes sir, 3 bags full. And we will stop it at that. Now we will hold on, actually let's add another line here. So let's say, how about a nursery rhyme? And then we will call the insert separator function, and we will add a hyphen here. All right, now we can go back to the rest of our program. So we will define say goodbye, and inside this we will provide the name parameter, and then we print goodbye, comma, space, name, comma, exclamation mark, comma, and the separator parameter. Now, finally, we define our main function. Now, under this, we call your name. Oh, sorry. We say your name as the variable equal to input. What is your name? Then we call the insert separator function with a hyphen. Then say underscore hello, your name. Then insert separator. This time we will put the equal to sign. Then recite poem. And then insert separator, once again with an equal to sign. Then say goodbye, your name. Now we will call our main function. So it asks, what is your name? Let's go with Catherine. Alright, so as you can see, there is an error here. It says that the name, your name, uname is not defined. So that was just a little typo here. So now when I made a change and I rerun the code and I go with Catherine, it prints out the code as we wanted it to. So what we have done is, in the insert separator function, as you can see here, we have defined this function in such a way that it takes the separating character as an argument. Because of this, we can now use this function to separate lines with any character that we like and not with any specific character. We also modified the say hello and say goodbye functions in such a way that they now receive the name of the person that is being addressed as an argument for the function. As you can see here, say hello takes the name and say goodbye also takes the name. There are two advantages to this, as you can see. So the first advantage is that we can move the your name equal to input what is your name line to the main function so that we can pass your name into both of the say functions, the say hello and the say goodbye functions. The second advantage is that we can move the call to insert the separator out of the say hello function because the separator doesn't have anything to do with saying hello. Now, one thing to note here is that the terms parameter and argument are usually used interchangeably, but there is a difference that you need to know. The first is this: parameters are the variables in the function definition. They are sometimes called formal parameters. Arguments are values passed into the function and assigned to the parameters. They are sometimes called actual parameters. This is just a good thing to know while you are writing your code and while you're using parameters and arguments within your code. Now let's move on to using parameter names within function calls. When calling a function, we usually do something called passing in a keyword argument. This is when we specify the name of the parameter whenever we pass it into an argument. Let's have a look at this example. So we will define a function called divide with numerator, denominator, and then we will return numerator divided by denominator. And that's it. That's our function for now. Now, when we are calling this function and we want to print out the values, this is how it will work. So we say print divide. We call the function divide. And now we pass in the keyword arguments. So let's say we want to divide 10 by 2. So we pass in the numerator as 10 and the denominator as 2. Now we don't need to specify anything here that the numerator is equal to 10 and the denominator is equal to 2. We can directly just say 10 and 2. Next, we will say print. We will call our function divide. And over here, we will do this. Numerator equal to 10, denominator equal to 2. Next, we will say print, call our function once again, and this time we will put our denominator first. So we say denominator equal to 2 and numerator equal to 10. Then we have print. We call our divide function, and this time we just put 10 without specifying what it is, and then we say denominator equal to 2. Now let's run this code and see what happens. You can see that the result is the same. So usually we would not have to use parameter names in function calls, but using parameter names allows us to pass in the different arguments in an arbitrary order. So for example, even though we exchanged the placement of these two parameters here, so we put denominator first and then we put numerator second, the function still understood what the numerator is and what the denominator is, and it did the necessary calculation and printed the result. Now, as you can see in this last line of code, it is possible to combine non-keyword arguments and keyword arguments in this function call. But what we need to remember is that the non-keyword arguments come first, followed by the keyword arguments. Later on, we will also see that a function can be written to require keyword arguments. Now let's move on to an exercise. In this exercise, we have two main objectives. The first objective is to create a function called addNums, which would accept two numbers, add them together, and then output the equation. The second is that we need to create a function that inputs the numbers given here into the addNums function and then returns their respective sums. The two sets of numbers that we have are 3 plus 6 and 10 plus 12. So this is the sample output, which we need to be able to get as well. Now let's have a look at the solution. So we define the function addNums. We throw in the parameters here, num1 and num2. Now we define our variable total, which is num1 plus num2. Then we print num1, comma, plus, comma, num2, comma, equal to, comma, total. And that's it for this function. Now we define our main function. We call addNums, and within this we pass in the two arguments, which would be 3 and 6. And then the next one, addNums with 10 and 12. Now we call our main function. So as you can see, we get the result that we needed. We get 3 plus 6 equal to 9, and we get 10 plus 12 equal to 22. This function is flexible and it is reusable. That means it can be changed as needed and it can be reused as required. Now we will see what default values are. So parameters that do not really have default values, they require arguments to be passed in. We can assign default values to parameters with the help of the following syntax. So let's define a function. We'll just call it function name. And within this, we will say parameter equal to default. And then we tell the function to do something, and we throw in the parameter here. Now let's have a look at an example. So let's say we had our insert separator function. Within this, we say s is equal to, and we put the equal to sign. Then we say print s, 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 and we throw in the separator parameter here, which is empty. So in this code, we have made the equal to sign the default separator. So if an argument is not passed into the parameter that has a default value, we use the default value instead. Now let's have a look at this exercise, which uses parameters with default values. So in this exercise, we need to create an addNums function that accepts these given inputs. And a little note over here is that it's okay if the function prints out zeros for values that are not passed into it. So let's see how to do this. So first, we will define our function addNums. And within this, we will provide the different parameters. So we have num1, num2, and then we give a default value from num3 onwards. So we say num3 equal to 0, num3 equal to 0, we have num4 equal to 0, and we have num5 equal to 0. Now within our function, we say total equal to num1 plus num2 plus num3 plus num4 plus num5. Now we print num1, comma, plus, comma, num2, comma, plus, comma, num3, comma, plus, comma, num4, comma, plus, comma, and num5, comma, equal to, let's add spaces here, and then we print out the total. Now we will we exit this function and then we define the main function. We say addNums 1 and 2. Once again, addNums 1, 2, 3, 4, and 5. Then we have addNums 11, 12, 13, and 14. Then we have addNums 101, 201, and 301. Let's just have a quick check to make sure we have written this correctly. So we have 1 and 2, we have 1, 2, 3, 4, 5, we have 11, 12, 13, 14, and we have 101, 201, and 301. Great. Now we we call our main function. And as you can see, the program prints out the values of these different function calls. And wherever there is no other value for num3, num4, and num5, the program prints out 0. So as you can see here, for the first function call, we just had 1 and 2. So over here we did 1 plus 2, and the rest of it came as 0 plus 0 plus 0, and then it printed out the value. So by giving the last three parameters the default value of 0, we have made them optional. But the first two parameters do not have default values, so they are definitely required. Now let's talk about returning values. Functions can return values. As we have seen so far, we use the addNums function to return the sum of the different numbers that were passed into it, and this function prints out the sum of these different values. But it is possible that we may want to return the value of the function or the result of the function and probably print them out in a different way. So for example, if we consider the addNums function, we can change this function in such a way so that it adds the numbers together, returns the sum, and then our program can decide what we want to do with the sum that is given back to us. So let's take a look at this code. So we will define our function addNums. We will insert the parameters num1, num2, num3 equal to 0, num4, and num5. Right, sorry, num4 is also equal to 0 and num5 is equal to 0. Now within our function, we define total equal to num1 plus num2 plus num3 plus num4 plus num5. And then we return the total. Now we define our main function. Within this function, we define result equal to addNums 1 and 2, and then we print the result. Next we have result equal to addNums, and this time we take the previous result and we add it with 3. And then we print result. Then once again we define result and we say addNums. We take the previous result, add it to 4. We print the result. Then we have result addNums we say result plus 5. We print the result, and once again we have result equal to addNums result plus 6, and we print this result. Now when we call the main function, let's see what happens. So as you can see, the function took the first two numbers, 1 and 2, and it printed the result here, 3. Now the second time, the function takes 3 and adds 3 to it and prints out the result 6. The third time, once again, the function takes the previous result, which is 6, adds 4, and gives the value 10. And likewise, it continues to give the values of 15 and 21. So basically, we have assigned the value of, or rather the result, of each particular function call to a local variable that is named result. Then we display this result and we pass it back to the addNums function in later calls. One thing to note here is that when a function has returned a value, the function is finished executing and the control is transferred back to the code that invoked the function. This is what we had seen here. Now let's have a look at importing modules. Now one really great thing about functions is that they are reusable. So it is possible that we can make use of our functions elsewhere in various other programs, and other programmers can also use our functions and modules that we create. Modules can import other modules with the help of the import keyword. So let's have a look at this example. So we say import add nums with return. Then we say total equal to add nums with return. Underscore return dot add nums 1, 2, 3, 4, and 5. And then we print the total. So in this example, we can say that if we had this module add nums with return, it also can import add nums within it and then print the value overall. Now, a note here, it is common for a module to check to see if it is being imported by checking the value of the special name variable. Such a module will only run its main function if the name is equal to the main, indicating that it is not being imported. The code usually goes at the bottom of the module and looks something like this, as shown below. And just note that these are two underscores used here and also here. Alright, so now let's look at a way to import functions from another module with the help of the following syntax. So we have from module name import function 1 and function 2. Now when we have a look at an example, let's say we had, once again, we had the from add nums with return module, and we import add nums. So then the total would be add nums 1, 2, 3, 4, 5. And then we would print the total. So usually when using this approach, it's not actually necessary to prefix the module name when we are calling the function, but it's possible to have naming conflicts, so we just need to be careful here. Now, another option that is extremely useful, especially when we have modules with long names, is to create some kind of an alias for the module, or basically something like a nickname for the module. This is just useful so that we don't have to type in the full name of the module. So, for example, we can say import add nums with return as ANWR. And then we would say total equal to ANWR dot add underscore nums and provide the values here 1, 2, 3, 4, 5. So using this method of calling a particular module helps us to avoid any kind of naming conflicts. Now let's take another example to see how aliases can prevent naming conflicts. So let's say we had a module foo. So from foo we would import do this. Now let's say we had a module bar. So from far we can import do this as do that. So there we go. So that's how we can use aliases within our program to make the process of importing modules a little more convenient and efficient. Now let's take a look at module search paths. The Python interpreter needs to locate imported modules. So when the import function is used within a script, the Python interpreter searches for the module that is being imported in the following places. So first, it would search the current directory, which would be the same directory as the program that is being run. And second, it would search the library of standard modules. We can take a look at these different paths by running the following code in our Python shell. So first, let's go to our command prompt. Now that we have our command prompt open, we will enter our Python interactive shell. We do this simply by typing in Python. There we go. Now we have entered the Python shell. So the first thing we do is import sys. Then we say sys.path. So this gives us a list of different paths which are searched by the Python interpreter to find the particular module that we are trying to import. We also have something called PYC files, which are created with the .pyc extension. They are compiled Python files which are created so that the modules that we import don't have to be compiled each and every time that they are run. They are automatically created in the PyCache folder the first time that a file is imported, and we don't really have to do anything with them. They work on their own. They automatically create and update each time that we import the modules, and they don't require anything from us. Now let's see the difference between methods and functions. So far we have seen some of Python's built-in functions like input and print. We've also learned how to write some functions of our own. In future lessons, we will learn how to use more of Python's built-in functions, and we will also learn a little more about methods. For now, what we need to know is that methods are very similar to functions, but they are called on an object. And the syntax that we use is the object's name dot the method's name. So let's take a look at an example of a very simple built-in function. This function is the len function, which gives us the length of the object that is passed into it. So for example, let's say len, and let's type in a random word. Let's say we type in the word programmer. The word programmer. Okay, so we have run into an error because we have not told Python that this is a string. Now when we run this, it gives us the number of characters within this string, which is 10. Now, an example of a method is this, upper. The upper method returns the string that is passed into it, but it converts all the letters into uppercase letters. So for example, let's say once again that we had the string programmer. There we go. Now we would say dot upper, and when we run this, it provides the same string but in all capital letters. Now these are just some very simple examples, but we will learn more about functions and methods in future lessons. And there we are. So in this lesson, we have learned how to define functions with and without parameters. We have also learned about the scope of a variable and how to import various modules.